Okay, good morning class. So you guys had some homework, and the homework was on page 30 20. Duty. Okay, so we were on page 20, exercise 8. Any issues there? 3 point? 3 point. You got it, okay. Any other problems with exercise 8? No? Then I gave you the revision exercise to do, not so? Okay. So I gave you up until question 8. No? Right. So for homework I wanted to do number 10, 11, 12 and 13. 10, 11, 12 and 13. Okay, that is for tomorrow's lesson. Okay. At the end of this chapter, we then take those the revision exercise, and then we will look at all the sums that you had an issue with in one lesson. Okay. So you must do as we're moving along. You must just do as I'm telling you. Whatever you don't understand, you can either ask each other, or towards the end of this chapter, we will just round everything up. Okay. So now we're looking at practical applications of number patterns. Practical application. And I think we're on page 21. Hi, Miss. How are you doing? Good, good.
Tanya looks to do. Is she on this class?
She is, Miss. Taking a bit longer than expected. Okay, so practical applications on page 21. Now practical applications is basically real life situations. Okay? With things that happens, that could happen on a daily basis, or as I said, in a real life story setting. Can you see this diagram here? Okay. It is redrawn there. Can you see it's exactly the same diagram? You all agree it's the same diagram? Okay. And this is on page 21. Okay, so we're told that the large red square has sides of 12x centimeters. As you can see here, that looks like 6 and 6, right? But the whole length here is 12 and 12. Okay? If they say square, there should 7 properties should come to mind. What are the properties? All sides are equal. All angles are equal to 90 degrees. Opposite sides are parallel. Diagonals bisect each other. Diagonals bisect the vertex angle equally. 2 more. Diagonals are perpendicular to each other. And the diagonals bisect each other equally. So whenever they tell you that something is a square, those 7 properties should come to mind. Okay? All sides are equal. Did I say that one? Okay? The diagonals bisect each other equally. And the diagonals bisect each other at 90 degrees. Okay? Those are the 7 properties of a square. So if they tell you square, that must come to mind. If they tell you something is a parallelogram, 4 properties come to mind. What are the 4 properties? Opposite sides are equal. Yes. 2 pairs of opposite sides equal. Diagonals, yes? Bisect each other. Not equally, but bisect each other. Opposite sides are equal. 2 pairs of opposite sides are equal. The first one was 2 pairs of opposite sides are parallel. And one more. Opposite angles are equal. Those are the 4 properties of a parallelogram. So if they say it's a parallelogram, that must pop to mind. They say it's a rhombus, 6 must come to mind. They tell you it's a kite, 5 must come to mind. Okay? We will list the kite and the rhombus on another day. But here we are busy with a square. So those 7 properties should come to mind. The large red square has sides of 12x centimeters. The midpoints are joined to form the given square. Okay? So there's 12. 12. If we join the midpoints, then what is half of 12? 6. So there goes 6 and there goes 6. How do you think they got 6 root 2x here? Remember, this here is 90 degrees, not so. Remember, this is 90. You know, this is 90 degrees here. So how are you going to calculate this then? The 6x squared plus 6x squared equals, let's call that the hypotenuse for now. So that's going to give you 36x squared plus 36x squared is 72x squared equals your hypotenuse side squared. Not so. The square root thereof, the root of 72 is going to be 6 root 2. X is equal to the hypotenuse side. So how did they get 6 root 2? They applied Pythagoras. You guys understand? Then we are told the midpoints are joined to form the green square. Okay? The midpoints of the green square are joined to form the purple square. So as you can see here, so we join that. So what they do then is they take the midpoints again. All the sides, the midpoints. And they join it. Then they get a purple square. And what do you notice? They join the midpoints again. And they form that triangle. That square and so on. You get the idea? How do they get How did they get to 6x? Remember, this is the midpoint. This is the midpoint of this length. So what is the length of that side of that triangle then? Sorry? 3 root 2 x. Not so. 3 root 2x. Apply Pythagoras, you're going to get 6x. Not so? To get this length here, it's going to be half of 6x, which is 3x. So that's also 3x. Apply Pythagoras, you get 3 root 2x. And so on and so on. You guys understand? You all okay with it, no? So let's read the question now. The green squares are joined to form the purple squares. This process is repeated indefinitely. So indefinitely, what does that remind us now? If you read indefinitely. Sorry? The sum to infinity. So somewhere the sum to infinity is going to fit in here. If they say carries on forever or indefinitely, then sum to infinity. Okay. And what is the sum to infinity? Who can remember? What's the formula for the sum to infinity? Is infinity equals a over 1 minus 1. Not so? But what's the condition for r here? R must be greater than negative 1 but less than 1. That's a condition for the sum to infinity to exist. Okay. And the series will converge also even if r is between negative 1 and 1. Calculate the sum of the area of all the squares that are formed this way, including the large red square. Okay, so the question is to calculate the area. So we must generate a number pattern for the area of this triangles. These are squares. Does it make sense? So let's look at the first triangle. Why am I calling it a triangle? The first square. How do you calculate the area of a square? Side times side, side square. So what is the length of the side? 12x. What's the length of the side? 12x. So what will the area of the first one be? 12x times 12x. 12x squared, which is 144x squared plus. So that is the red one. Not so? Let's look at the area of the second piece. Sorry about this one. Board is not playing along. I need to restart the computer. But as you know, we started the video already, so just struggle along. Let's look at the next one. Colors are going to change. Let's look at the next one, the green one. Exactly. So what is the length of this line here? 6 root 2 x. This length here? 6 root 2 x. So how do we calculate the area of the green one? 6 root 2x all squared. That's side squared. What could I say? 6 root 2x times 6 root 2x. Okay? And what is 6 root 2x times 6 root 2x? 72 x squared. Not so? 72x squared. x squared. Okay. Let's look at the one in purple. There we got that length now. So what's the length of a side here? 6x. So the area of the square is going to be 6x all squared. Not so. It's plus 6. No, 6x all squared is going to give you 36x squared. And so on and so on and so on. You see how I've generated a number pattern here? Now in practical applications, they will give you always a scenario, a real life problem, scenario, and then we would form a number pattern out of that. Does it make sense? We will form a number pattern out of it. So if that is my sequence, what is my A value? If that's my sequence, what's my A value? It's going to be 144x. What's my R value? It's going to be T2 over T1, which is 72x squared over 144x squared, which is simply R. Does R4 lie between -1 and 1? Yes. So the sum to infinity will exist. The series will only converge if and only if R is greater than -1 but less than 1. Does it make sense? And this is the case. So the sum to infinity, we wrote down the formula again, I'm not going to write it down again, equals, what's my A value? 144x over 1 minus, and what's my R value? R. So now you put that in your calculator.
So,
Yes?
why don't you use 144x squared?
Should have been 144x squared. Yes, absolutely. It should be 288x squared, no? It's 288x squared, units squared. Okay. That is how we work out the sum to infinity. Any confusion? People, you must get a real life application sum in your exam. Okay? And this is fairly simple. This topic is fairly simple. So this is your crunch question. Okay, the question you must think about. If the sum had to come in as it is here, it will be probably three marks for the sum, 3 or 4 marks. Okay, so it's worth understanding what to do at this point. Okay. Any questions? I'm moving too slow, no? Yes. Okay. We'll try and move a bit faster. Let's look at worked example 2. Yeah, they told you that Greenworks, a project started in 2007 by a former South African president, Thabo Mbeki, aims to plant 1 million trees a year in South Africa. Okay, South Africa is more busy with other things now than planting trees, not so? This is on page 22. Okay. So we are told that at the end of the first year of planting a tree, don't write the whole question down, just write the reference. No? It's example 2 on page 22. So at the end of the first year after planting a tree, the tree is 1 meter tall. Okay, so once the tree is planted, 1 year thereafter, 1 year have passed, the tree is 1 meter tall. In the second year, its height increased by 56 centimeters. Okay? So if I must set up a number pattern for the height of the tree, what would have been the scenario now? It would be, we'll start with 1, yes? Is enough for the height, no? It will be 1. Then 1 comma 5, 6 and so on, no? That's for the height of the tree. Not so. In each successive year, what does successive mean? Every year that follows. So year 1, year 2, year 3, year 4 and so on. Every year after that, successive. In every successive year, its height increased by 7/8 of the previous year's increase in height. Okay. So that value, is that the D or R value? It's R value. Why? Because it's 7. It increased by 7/8, or 7/8 of the previous year. So you have to multiply the height that is increased by 7/8 every successive year. That's number 1. What do you know also about 7/8? And with regards to R? Sorry? 7/8, yes? It's in between, yes? Negative 1 and 1. So what does that mean? The sum to infinity will exist. Or the series will converge if asked. Does it make sense? Okay. So if the previous height increased by 7/8, what would we have now? The first of this is the height of the tree. No? This is the height, and this is what is increased by. Okay. So after the first year, it increased by 0.56. Not so. Or I could have converted everything to centimeters. Is that okay? You want me to convert everything to centimeters? Okay, otherwise the sum is going to be fairly small, the values. We're going to work with lots of decimals here. So the height of the tree would be simply 100 in the first case, then 154, then. But the increased height, 156, sorry. The increased height in the first year is going to be 56. In the second year, it's going to be 7/8 of that value. Not so. It's going to be 56 times 7/8, which is 49. Okay? What will the next one be? Will be 49 multiplied by 7/8, which is, sorry, 42,875. You all okay with that? And so on and so on. Okay. So the question says, in number 1, determine the increase in the height of the tree in the third year. Did they ask you for the height of the tree in the third year? No. They wanted to know the increase in height in the third year. So that, sorry?
So why the height is 146 and 146 centimeters?
This was 100 centimeters.
No, the last one.
Plus 150. In the third year it will be 156 plus 49, which will be what? 205. We add 42,875. What should that be? 247,87. Not so. But this, what does the question ask? The question says determine the increase in height of the 3 in the third year. So what would the increase in height then be? That is in increase year 1, not so? Year 2, and that is the third year. So it's going to be for year 3, the third year will be 42,875 centimeters. Okay. Let's check around for it. But does it make sense? Nope, I'm not correct. This is year 1. This is year 2. This is year 3. Does now make sense? Does it realize now? That's why I needed to check. That goes with that one, that goes with that one, and so on. So you all agree it should be 49. Yes. So year 3 is going to be 49 centimeters. Why? Because after the first year it went up by 100 centimeters. The second year, the increase in height is going to be 56 centimeters. The third year, the increase in height is going to be 49 centimeters. Okay, so made a mistake there, sorry about that. Let's look at number 2. Number 2. Determine the total height of the tree after 3 years. Okay, in this case we would have picked it up that we made a mistake anyway. So after the third year it was 100, after the second year is 156, and after the third year is 205. So year 3, the height would be 205 centimeters. Okay. Any confusion here? So we have a case here where in number 3, Lobelo says that by the end of the 5th year, the tree will exceed a height of 3 meters. So in other words, I can work out what the tree's height is after 5 years to confirm if Lobelo is correct or not. Okay? By working out term 4 from the increase in height and then add it to the total. Okay? Or, okay, and we read on 3 meters. Tabu disagrees with him and says that the tree will only exceed a height of 3 meters after 6 years. Okay? So in other words, I can work out the sum of the height after 6 years using the formula. Is either of them correct? The question says fully justify your answer by means of calculation. So let's look at the first case. Here we can make this up a bit. So we go with Lobelo. So he says at the end of 5 years. So let's calculate the height after 5 years. So the tree starts off with 100 centimeters. Now the 100 does not conform with the pattern at hand. Not so. Because I don't multiply 100 by 7/8 to get 56. I do multiply 56 by 7/8 to get that, 49. Then I say 49 multiplied by 7/6 give me 42,875 and so on. However, to get 56, I don't multiply 100 by anything. So which means to say at that point, to get the first term of the increased height, it does not conform to that pattern. Does it make sense? So normally, when I move from one term to the next, just like anyone here, if I move from one term to the next, it's the first term that I multiplied by 2 over 5, then multiplied by 2 over 5. Can you see that? We go further on, that is arithmetic. Move further on, geometric, here should be a pattern here. From the first term, I multiply that by 3, then I multiply that by 3. Does it make sense? Because if you look at the increased height here, that 100 is not playing along. You notice that? So the numbers that conforms to the pattern only starts at 56 onwards. That is why when we're going to work out the height of Lobello's argument, we have to say it's going to be 100 plus the increased height here. The sum of 56, 49, 42, and so on. For how many years is Lobello talking about? He's talking about it being for 5 years. This is year 1 already. 100 is for year 1. So how many years must I work it out then for? 4 years. Does it make sense? So what do I use here? To calculate the sum of these values for 4 years, I must use the Hcn formula, which is A into Rn minus 1 over R minus 1. So for S4, your A value is going to be 56 into R, which is 7 over 8, raised to the exponent 4 minus 1 over 7 over 8 minus 1. Okay? So it's 100 plus 54 into, no, is it 56? Now why don't you tell me? You will let me now do the whole calculation and I see I'm wrong and then you tell me it's 56. Tell me immediately. Right. Don't be shy, ne? 56 into 7 over 8 to the exponent 4 minus 1 over 7 over 8 minus 1. That gives me a height of 285,39. So it's 285,3 meters and centimeters. So Lobello says that at the end of the 5th year the tree will exceed. What does exceed mean? Must be more than 3 meters. Is Lobello correct? No. So Lobello is not correct. Okay, right then. Therefore, Lobello is not correct. Okay. Let's look at, who's the other one? Tabu. Okay, Tabu's argument. Let's calculate his story. Sorry about this. Is this irritating? What is this? Okay. Different color. Okay, so the other person is Tabu. Okay, so Tabu says that after 6 years, the height will exceed 300 centimeters, or in this case 3 meters. So again, that 100 does not conform to the pattern. So that is going to be year 1. So how many years must I still account for? For 5 years. Why? Because the Tabu was talking about 6. So that is year 1 and then 5 years. So it's going to be 56 into 7 over 8 raised to the exponent 5 minus 1 over 7 over 8 minus 1. Okay, so that's easy picking here on this. Just changing the 4th away. Fine. So Tabu comes to a value of 318, comma. That is going to be 318, comma 22. Is this exceeding 3 meters? Remember that is centimeters or 3,18 meters. So therefore, Tabu is correct. Okay, in his statement. Tabu is correct. Okay. Now in question 4, can I take this off? We're still writing? Okay. So now in question 4, question 4, it says calculate the maximum height to which the tree will grow. The maximum height that the tree will grow. So after how many years will it reach a maximum? Or for how long will the tree grow for? Infinity. Not so. So whenever you read maximum height to the maximum length of something or so on, you would need to know it's going to be the sum to infinity. So how are we going to work out sum to infinity? This is infinity is equal to a over 1 minus r. Does r lie between negative 1 and 1? Yes, that's why the series will converge. So what's my a value here? It's going to be 56 over 1 minus my r value 7 over 8. And this, the original height in the first year, which does not conform to the pattern, is going to be 100. That's simply going to be 100 plus 56 over 1 minus 7 over 8. That gives you 548 centimeters, which is 5,48 meters. Okay. So these 3 people will never ever go over 5.5 meters, ever. You can test it using the calculator as well. Let's go and say, let's find out what the tree has grown after 50 years. You see it's 5,47 meters. Can you see that? Let's make 500 years. It's 5,48 meters. This value will never ever go over that. If we take it even in the time of the dinosaurs, how many years ago the dinosaurs lived? More than 1,000 years ago, no? Or 1,000,000 years ago. I never took note of those things. I was doing maths in those periods. Can you see that? It will never, that tree would have never gone over 5,48 meters. Can you see that, people? And infinity is a fairly large number. Not so? And that amount of years is also large. 15,000 years ago. Okay? Go millions of years ago. Same story. According to this model, this tree would never go over 5,48 meters. You guys understand?
So,
Yes. Ask.
you see, there was a question also maximum height.
Maximum height, yes.
35 from would use increase.
But remember, how did we get this height column? We took the increased height and we added to 100. Then we took this increased height and add it to that value. We took the increased height and we added to that. That's how you get it. Do you understand? Or we could have said that. So it's going to be, let's go for year 3. For year 3 we say, here's my highlighters. Let's go with year 3. No? So we say, that is year 1 plus the first increase and the second increase. That is how I get this value here. Can you see? So what did we do? For year 3 we took 100 plus this one plus that one. So year 3 consisted of year 1 and 2 of the numbers that conforms to the pattern. What if you go with this value here? So that is year 4. But year 4 consists of 100, which is year 1, and 3 of these values here. That's how I get 4. That is why when I work it out, I always say 100 first, which is coming from here, plus the numbers that conforms to the pattern. Okay. Anything else? There's another sum like this coming in the revision exercise. Okay, that we can look at again, to do with the shrubs or whatever. Example 3 is dealing with recurring numbers. That is never asked in the exam. Okay. So for homework is exercise 9. I want you guys to do number 1, 2 and 3. I'm not going to give you a lot of this because I know it becomes a bit confusing. So please try and do all 3 of it, and then we will discuss what the issues are. Okay, you all okay with that? Right, so I'm going to give you a chance to start with this now. Exercise 9, number 1, 2 and 3, and this is on page 23.